Good morning, students. I welcome you all to Brihan Mumbai Municipal Corporation Education Department, online education for English medium. Today we are conducting for class 9. Subject is science and the topic which I am going to teach you today is chapter number 3, that is current electricity. And in that, the subtopic which we are going to see is Ohm's Law, resistance and resistivity of conductor. Today is the second session for this chapter. My name is Ms. Bushra Maksud Ahmed and our Chief Nodal Officer name is Mrs. Almaz Hanore. Let's start with the chapter now. So what's the chapter? Chapter number 3, current electricity. Now see, by seeing the name only, current electricity, what comes in our mind? Electricity, right? There in day-to-day life, there are numbers of appliances which works on electric current. We all know, right? Mama says not to touch the switchboard. Why? Because current is flowing in it. Current is dangerous for us also. But in the second side, if we will see, nowadays electricity is the main purpose. Without electricity, not a single appliances will work. There are numbers of appliances which work on this electricity. What are these? Let's see. We know AC, air condition. See the first image. First image is what? Air condition. Air condition also work on electricity. It gives us cool air. Then this is electric kettle. Electric kettle, what we heat in that? Water. We make coffees in this electric kettle, that also work on electricity. Then there's weighing machine. This is used by doctors, right? um, if we want to check our weights, what we use? We want weighing machine, and it also works on what? Electric current. Then to iron your shirts, what you tell, mama, my shirt is very wrinkled, I want to iron it. But for this ironing, what is used? Electric iron is used, and it's work on which? It works on electric current. Then we all have what? This big image, that is refrigerator. Refrigerator, we store the things. If we keep our foods outside, it will get we get a bad smell of it. It will decompose easily. But when we keep the foods in fridge, we can store it for long period of time. While if we keep it outside, what? We can't store it for long period of time. It will get waste of thing. So for safety purpose also electricity is used, right? So fridge works on what? Electric current. Then in TV, we watch our favorite cartoons. Then animals, Discovery channels and everything. So it's also work. This television works on what? Electric current. Then swing machine, fan, washing machine. This all are, there are again numbers of appliances which are very helpful for our day-to-day life, which we can't live without that. And this all works on what? This all works on electric current. Nowadays, without electric current, we can't imagine to survive, right? Without electric current, numbers of appliances will not work. If one day also electricity is not there, so we know what is the condition of our day-to-day life. Okay, so now in this lecture we will see what is electricity, what are the things related to this current electricity, how it works, what is exactly current electricity, that we are going to learn. Okay, now see, in last session yesterday Vishal sir has taught you something about current electricity. What he has taught you? He taught you about potential and potential difference of a cell. Then he also has taught you about free electrons, electric current, right? This all things sir has taught you yesterday, na? Now we are going to see the next small revision we will take, and we will continue to our topic then. See, first we will learn about potential difference of a cell. What is potential difference of a cell? See, potential. Now we will see the term potential difference. Potential difference means, potential means strength, and difference means we can tell it that difference between the two potential. So we termed it as potential difference. Okay. Now see, potential difference of a cell. First we will see the first point, the difference in potential between the positive and negative terminal of a cell is the potential difference of that cell. See, it's very simple it is. Now see, the difference in the potential. The difference in the potential, in which the difference between positive and negative terminal of the cell. In cell, how many terminals are there? Two terminals are there, positive terminals and negative terminals. So both are having different potential. Positive terminal is termed as higher potential, while negative terminal is termed as lower potential, right? So the difference in the potential between positive and negative terminal of a cell, that is termed as what? That is termed as potential difference of that cell. Understood this first point? Now we are going to the second point. This potential difference is caused by chemical reaction occurring inside the cell. Now you will tell me, ma'am, why there, if there is two terminals, so why they are having different potentials, right? So how this potential difference is occurring? This potential difference is caused by what? It is caused by chemical reactions occurring inside the cell. In cell, whatever chemical reactions are occurring, right? Due to this chemical reaction, there is a difference between the two terminals, positive and negative terminals. There is a difference between the potential of these two terminals, positive and negative terminals. Okay, this much understood you? Now we are going to learn, we will see the third point. The potential difference sets the electrons in motion and results in the flow of electricity through a conducting wire connected to the two ends of the cell. Now you'll tell me, ma'am, you have read so big line, we have not understood anything. See, we will see now what this means. We will go word by word so you can understand it very well. Now see, the potential difference sets the, now see, in the first 2 points what we have seen, that in two terminals there is potential difference. Now how this differences occurs? It is occurs by what? Chemical reaction. Now what, due to this, what setups? Now see, the potential difference sets the electron in motion. Now whatever electrons are there, due to this potential difference, they sets into the motion. And as the electron sets into the motion, what it results? It results in the flow of electricity. It results what? Flow of electricity through a conducting wire. Okay? And conducting wire which is connected by the two end of the cell. Now see, there is one cell, we are in cell there are two ends, right? Positive and negative. And when we connect a conducting wire into it, there will be what? There will be difference in the potential. Potential difference will occur. As potential difference will occur, electron will set into the motion. As the electron will set into the motion, what we will see? We will see the result, that is there is will be a flow of electricity in the conducting wire. Okay, so this is all the concept which we understood what is actually potential difference. Now if we will be given some numericals to find out the potential difference, so we want some formula, right? Now for that purpose we want to learn the formula how to calculate the potential difference. Now see, potential difference between two cells, between 2 points. Well, always we measure potential difference. Whenever we will measure potential difference, we will always need 2 points, two terminals. Why? Right? If there will be no two terminals, there will be no difference in the potential. For that reason, whenever we want to calculate potential difference, what we require? We require two terminals. We require 2 points, right? So whenever what is the formula then? Potential difference between 2 points equals to work divided by total charge transferred. Work will be what? Amount of electrons which are flowing, the work which is going to be conduct, that work divided by total charge transferred. How many charge are getting transferred in the conducting wire? That is nothing but potential difference of that cell. Okay, now what will be the SI unit of that? SI unit is what? SI unit of potential difference is volt. And what will the symbol of it? It will be capital V. So hope you all have understood what is potential difference now, right? It's very easy it is. Now we are going to learn about the next point, that is electric current. Now this is the very interesting topic, electric current. We will see that. See the first point, an electric current is the flow of electron through a conductor. Now only I have told you when electron will be set into the motion, what we will see? We will see there is a flow of electric current, right? Now see, I will explain you figure after we will finish the above points. Okay, just first concentrate on the above point, then we will discuss about the figure which is shown. Now see, current I is defined as the charge passing through a conductor in unit time. Now, how to measure, how to define a current? Potential we have, potential difference we have learned. Now, what is current? Current is defined as what? Current is defined as the charge passing through a conductor in a unit time. In a unit time, whether we take the unit time as 1 second, 1 minute, or 1 hour. Okay, the amount of calculation which we are taking, it depends on that. So in a unit times, for that only we have used the term unit time. Otherwise we can take it as 1 second, right? So why we use unit time? Because when we are solving the numericals, sometimes in unit time what we have to take 1 second also, 1 minute also, or 1 hour also. So for that reason, in a unit time, how many charges are passing in the conductor? In unit time, whatever the number of charges which are passing in the conductor or a conducting wire, that is termed as what? Current. And what is the symbol of that? It is capital I. Second point you have understood. Now we will go to the third point. Even though electrons moves from negative end to positive end, conventionally the direction of current flow is taken to be opposite of the direction of flow of electrons. That is from positive end to the negative end of the cell. See, this is very interesting point. Now see, when we have connected our batteries or a cell, what we see that electrons flows from negative to positive terminal, because electrons are negatively charged, right? So it will get attracted to a positive the terminal. But what we see, what is the direction of conventional flow, conventional current? We will see that the flow of current, the current which is flowing, is it what? It is opposite to the direction of flow of electron. That is, it will flow from positive to negative. Now see, concentrate on this figure. See here, it is shown that electrons, right? With a blue line, the direction of electron flow is shown, and above with the red line, what it is shown? Conventional current flow, right? Now see, this is negative terminal, this is positive terminal. Now when we have connected batteries above, right? The thick one is what? It is cathode, and the big one is anode, right? Now see, electrons are flowing from negative terminal to the positive terminal, while what is the direction of conventional current? It is flowing from positive terminal to the negative terminal. So always remember, students get confused, right? What is the flow of, ma'am, how it is electrons flows and how the current flows? These are the opposite things with each other. See, electrons flows from negative terminal to positive terminal, while current flows from positive terminal to negative terminal. Understood this thing? Now what is the formula to calculate it? Current equals to I equals to Q upon T. Now you'll tell me, ma'am, what is Q and what is T? Q is nothing but charge, right? Number of charges which are passing. And T is a unit time, that is time which is taken out. Now the SI unit of charge Q is Coulomb C. Now what is the SI unit of charge? charge is always termed as SI unit is nothing but coulomb. And what is the symbol of coulomb? It is capital C. Now, current is expressed in ampere. The current which we are saying, that current SI unit is what? Ampere. And its symbol is capital A. So hope you'll all have understood very nicely what is potential difference, what is electric current. Now, if I will explain you Ohm's law, you will easily able to understand it, because now you have very well understood what is potential difference and what is electric current. Now we will go to a point, that is Ohm's law. Now see, resistance and Ohm's law. Ohm's law, the relationship between the current flowing through a wire I and the potential difference across its end V can be obtained from the law that was given by the German scientist Simon Ohm. Now see what I have taught you, the two topics right now: current, electricity, electric current, and potential difference. Now see the relation between these two things, that is electric current and potential difference. This is stated by a one law. The relation between these two is stated by a law, and that law is given by which scientist? There was one German scientist whose name was Simon Ohm. Now what he has stated, we will see that. What is the statement of that Ohm's law? We will see that. If the physical state of a conductor remains constant, the current I flowing through it is directly proportional to the potential difference V between its two ends. So this was a statement of Ohm's law. Now you'll say, ma'am, we don't understand anything. You have just read it. We don't know what the statement means. Now see, we will go word by word. Okay. Now see, if the physical state of the conductor remains constant. Now what is physical state? Physical state of a conductor means what? The physical state of a wire, whatever the conducting material is that. So physically, what will the physical appearance, right? So what it will be, physical will be, it might be the length of the wire, length. Okay. Now area of cross section, how much thickness is there, how much area is there of that wire, that we will see. Then the temperature, at which temperature that wire or the conducting material is kept, and the material it is made up of which material that conductor is made up of. So what are the physical state of means? The physical state means length, area of cross section, temperature, and material which it is made up of. Okay, so you understood what this first line means, if the physical state of the conductor remains constant. Now this all the things which I have told you, length, area of cross section, temperature, material, it is made, this all physical state when it remains constant means when it does not change. Okay, when it does not change, it is constant hai. There is no variable, there is no change. So at that time, what is there? The current I flowing through it, the current which is flowing through that conductor is directly proportional to potential difference capital V between its two ends. See, very interesting. If the physical state of that will be remains constant, then whatever the current which is flowing in that conductor will be directly proportional to the potential difference V of between this. Now you will tell me, ma'am, directly proportional, you are telling, what is meaning by directly proportional? See, in the symbolic form here I have seen you, that is I is directly proportional to V, means current is directly proportional to the potential difference in the between the two ends. Directly proportional means what? If the current will increase, potential difference will increase. If the current will decrease, potential difference will also decrease. Hence we term this as directly proportional. Okay, when we tell it is inversely proportional, so what is inversely proportional? If one increase, then other decrease. If the other decrease, then the next one increase. That is inversely proportional. When we term is at directly proportional, it means when one term increases, the other one also increases. Here, what is the scene? When current will be increased, voltage will also increase. When current will decrease, voltage will also, sorry, potential difference will also decrease. Okay, now when we remove this proportionality sign, so what we have to keep there? A constant of proportionality, constant term. So I equals to K into V. So what is K in that? When we remove this proportionality sign, we keep it equal to and constant term. So K is what? Constant of proportionality. Now when I take K from right hand side to left hand side, what? It will go to the denominator. So it will become I into 1 upon K, because I am taking it from right hand side to the left hand side, right? So it will be I into 1 upon K equals to V. Remember, V is for potential difference, I is for current. Now see, 1 upon K equals to R equals to resistance of the conductor. Now see, 1 upon K, what we are taking, 1 upon K is equals to R, and that R is nothing but resistance of the conductor. This resistance I will explain you very nicely, very in detail. Just first see this, what we are taking right now. 1 upon K is nothing but what? It is R, and we termed it as resistance of conductor. Now, as I am putting the value of 1 upon K equals to R in the equation, what I will get? I into R equals to V, right? I into R equals to V. So hence what we will get? V equals to IR, or R equals to V upon I. Now see this formula, V equals to IR or R equals to V upon I. This formula is known as what? This is nothing but a Ohm's law. This formula we are always using to solve the numericals. Whenever we are trying to solve the numericals, what we use? We use this formula. Now see, V equals to I. V stand for potential difference, I stand for electric current, and R stand for resistance. Okay, now see, this is all about Ohm's law. Everyone understood what is Ohm's law now? Okay, now see, in this Ohm's law, one term comes into an existence, that is resistance of a conductor, which I have taken R. Okay, now we are going to learn about what is this resistance of the conductor R. Now see, before going to that, see, Ohm's law, we can obtain the SI unit of resistance from the formula. Now see, potential difference and current can be measured in volt and ampere respectively. The unit of resistance is called Ohm. The unit of resistance is called Ohm. It is indicated by the symbol Ohm. See, this is the symbol of Ohm. I will come one by one, just I'm reading out the points. Okay. Now see, we know that the potential difference SI unit is volt, and current what? It is ampere. And what is their unit of resistance? Unit of resistance is Ohm. Okay, and the symbol is, see, this is the symbol of Ohm. Now see here very nicely, to explain the resistance, this picture is shown, right? Now see, this is a height. Can you see here a height? So this man having a blue shirt and a brown pant, it is shown as volt. Volt is nothing but potential difference. Now see, potential difference, yesterday also sir have told you that always current flows from higher potential to lower potential, right? So to show the higher potential, we have taken a height which are having higher potential, and the slope which are going to the lower potential, right? And a man which is wearing a yellow t-shirt and a light pant is termed as what? Current, ampere, right? Ampere is written. So this current is want to flow from that conducting wire. What current is, the current is telling I want to flow from this conducting wire, right? But as there is a potential difference between the two ends of the terminal, this is high height, this is low height, there is a difference, right? Voltage is telling current to flow, but what is restricting current to flow? That is resistance. See that resistance, what he has come, he has just hold all the current, he is not allowing the current to go out. So what current resistance is, what resistance the obstruct is, it is obstructing, it is obstacle to the current, it is stopping the current to flow. So see, it is he's trying very hard to stop the current. No, I will not allow the current to flow. So see, this is the property. Voltage is what? There is a potential difference between high and low, which are helpful for the current to flow. And as current is flowing, resistance is what? Resistance is stopping the current to flow. So what is resistance? Resistance is that which is an obstacle. It is used to stop the maximum current which is flowing through the conductor. But for that also, for that ohm also, for that resistors also, it is very hard to stop the current. See, he's telling now, oh my god, he is very heavy, means the current is very heavy, it is very hard for me to stop him. But literally the current is flowing. So this diagram, this is a cartoon form of Ohm's law, which is now you can understand very well what is Ohm's law. Okay, you understood now what is Ohm's law, everyone? I hope so. You have very well understood the Ohm's law. Now we will go to the next point. Now see, what is resistance of Ohm's law? You see, you have learned about resistance, you have learned about voltage shift potential difference, you have learned about electric current. Okay, now what is resistance of 1 ohm? What is 1 ohm? Now see, yes, here's the 1 volt upon 1 ampere equals to 1 ohm. Whenever, see, 1 volt upon 1 ampere is equal to 1 ohm. We will see this now. If 1 ampere current flows through a conductor when 1 volt potential difference is applied through its end, then the resistance of the conductor is 1 ohm. See, very simple. See the formula below also I have given you. R is what? V upon I. What is the SI unit of potential difference? Volt. What is the SI unit of current? Ampere. So, when 1 ampere of current, when the 1 ampere of current is flowing through a conductor, and there is a difference, that is a potential difference is 1 volt is applied between its end, at that time the resistance of the conductor is always what? 1 ohm. Understood this? It is very easy. Now see, here is one photograph. One photograph of what? He is nothing but a scientist, German physicist, who has stated this Ohm's law. His name is what? George Simon Ohm. Established a law for measuring the resistance of conductor. Okay. George Simon Ohm established a law for measuring the resistance of the conductor. In his honor, the unit of resistance is called the ohms. Okay. Now to give the honor to this German physicist, what? The unit of resistance is given ohms. This ohms is given by its name. What is his name? George Simon Ohm. Now see, this is the photograph of George Simon Ohm. He was born in 1789 and he died in 1857. So see, so many years, before so many years, he has stated this Ohm's law. Now we will go to the next point, that is resistance and resistivity of a conductor. Now see students, see the first diagram, A small a1. We will see that the electrons are what? Electrons are in random motion. Random motion of electrons are there. So random motions of electrons in absence of flow of current in it. Now there is no wire. Now see, in the conductor, it is not connected by batteries, right? When there is no batteries connected, the flow of electrons are randomly, they are moving here and there, right? See, we can see that randomly the charges are moving and the electrons are moving. Now see, as we have connected the wires to the batteries, as we have connected, see, if you will tell ma'am, when we have not connected batteries, the electrons are in random motion. Now as I have connected batteries, I see that the what electrons are moving in a direction that is negative to positive. Why it is there? What this battery do? See, this battery creates the potential difference. If potential difference will not be created, current will not flow. So to create the potential difference, what we put? Battery is put it. Now see, as I put the battery, what? The electron set into motion, direction of electron flow. Okay. Now the collision of electrons with the positive ion, due to which the metal wires offer resistance. Now see, I will this B point I will explain you later on very detailed. First we will see, see everyone has seen this diagram now. Now we will see, go by one the points. Okay. Now see, as shown in the figure, there are a large number of free electrons in the conductor. They are constantly in random motion, right? We have seen this first figure now. They are constantly in random motion. So in that, there are large number of free electrons which are what? Constantly in random motion when there is no connection of batteries, right? Now when I have connected the batteries, when potential difference is there, now what the scenario is there? We will see that. When a potential difference is applied through the two ends of the conductor, these electrons starts moving from the end at lower potential to the end at higher potential, right? We have seen this point also, that electrons flows from what? Lower potential to higher potential, while current flows from higher potential to lower potential. That diagram you have seen now. See this diagram, current is flowing from higher potential to lower potential, but electrons is flowing from lower potential to higher potential. Second point also you have understood now. Now we will go to the third point. This directional motion of the electrons cause the flow of current, right? This directional flow of electrons, what? It causes the flow of current. We'll go to the fourth point. Moving electrons strikes the atoms and ions which lie along their path. Now see, we will see this. Now see, collision takes place. We see the ions here, positive ions. Can you see? Now see, whatever the ions, positive ions are present in this conductive ion, there is a collision between them. When electrons are moving from lower potential to higher potential, that is negative terminal to the positive terminal, what is there? The collision of electrons from the positive ions, due to which what occurs? There occurs a resistance. Now see, if I will just pass a small ball, and if some obstacle comes in between us, our other ball is also coming. So see, when they both collide with each other, so what we will see, there is an obstacle occurs, right? There is a hindrance occurs. As the obstacle will occur, so obstacle is nothing but what I told you, resistance. Okay, so as there is a collision of electrons between with this positive ions, what this metal wire experience? It offers what? It experience resistance. Resistance takes place. Okay, so this is the fourth point. See, moving electron strike the atoms and the ions which lie along their path. When they are moving to a path, they get strike to these atoms and the ions. Now see, such collisions causes hindrance to the flow of electrons. When the collision occurs between these ions, atoms and the electrons, what occurs? Hindrance. Hindrance means opposition. Opposition is nothing but obstacle, right? That hindrance flow of electron to the to oppose what? To oppose the current which is flowing through it. So this hindrance is called what? This hindrance is called resistance of the conductor. This is nothing but a resistance of conductor. And how resistance is caused? This is caused when electrons strike to the atoms and the ions. When they strike, so what? The opposition occurs, the obstacle occurs, the hindrance occurs, and this opposition, this obstacle is nothing but a resistance. I hope you all have understood it very nicely. What is resistance, right? Now we will go the resistivity. What is resistive? Resistance we have learned. Now we will learn about resistivity. Now see, at a given temperature, the resistance R of a conductor depends on its length, cross-section area, and the material it is made up of. Now see, at a given temperature, the resistance of the conductor, it depends on three things. It depends on its length, it depends on its area of cross-section. Sorry, two things. It depends on its length and it depends on its area of cross-section, and the third one is the material it is made up of. What is the material of that conductor? These three things it is. It depends on these three. Now how these are related with each other? Now see, R is directly proportional to length. Means resistance will increase if the length of the conductor will increase. Understood? It is directly proportional. For that reason, R is directly proportional to L, means if resistance will increase, if length of the conductor will increase, resistance will increase. If length of the conductor will decrease, resistance will decrease. What is second? R is inversely proportional to area of cross section. When we take inversely means 1 upon A, we will take. Inversely means when area of cross section increase, resistance of the conductor decrease. And when area of cross section decrease, resistance of a conductor increase. Therefore, when we just add up, when we just unite these two proportionality terms, what we get that R is directly proportional to L upon A, because R is directly proportional to length and it is inversely proportional to area of cross section. Therefore, we will term it as R is directly proportional to L upon A. Now see, previously also when we have removed this proportionality sign, what we have taken R equals to rho L upon A. As we have removed this proportionality sign, what we have told equal to rho L upon A, right? So what is this rho? See, this small p, little tilted one, small p, the symbol you are seeing now, that symbol is termed as what? That is termed as rho. Now see, rho is the constant of proportionality. Now rho, what we say, it is a constant of proportionality, and what we have termed this rho as, it is called as resistivity of that material. Now this rho is nothing but what? Resistivity of this material. See students, these all formulas are very important. See, if you will just see this formula, you can understand the whole concept. Okay, just don't mug it up, just understand them. If you will understand them, no, so it will be very easy for you to remember them. Okay, so just don't mug it up. So just understood what is the statement they are telling about, they are talking about. See, equation speaks to us. If we will just concentrate on the equations now, we will see that equations are speaking to us. Yeah, I am resistance. Yeah, I am length. If I will increase now, then resistance will increase. See, this is area of cross section. If I will increase, resistance will decrease. If I will decrease, resistance will increase. So when you will, very interestingly, when you will focus on the points now, you will see that study is also talking with you. So just concentrate, okay? Just make them understood. Now see, this rho is termed as what? Resistivity of a material. Now what is the unit of resistivity? Unit of resistivity is what in SI unit is Ohm meter. Okay. Now see rho, if I will take L upon A from right hand side to the left hand side, what we will see, rho equals to RA upon L. Okay. Now the SI unit of resistivity is Ohm meter. Now see resistivity is a specific property of a material, and different materials has different resistivity. Now different materials, since it depends upon the material, different materials have different resistivity. It not depend, see I told you now, it is depend also on material it is made up of. So if the conducting material is a copper wire, if a conducting material is made up of aluminium, it is made up of iron. So as the material will vary, its resistivity will also vary. Okay. So everyone has understood now resistivity also. Okay. Now we are going to see how. So now see how will you prove that the unit of resistivity is Ohm meter. Sometimes it is also asked in exams. So prove that the unit of resistivity is Ohm meter. Now see, we know that rho is what? RA upon L. Here only I have shown you R equals to rho L upon A. So when this will come to here, right hand side, L upon A will from right hand side, it comes to the left hand side. So it will become rho equals to RA upon L, right? So that formula I have taken rho equals to RA upon L, and I termed this as equation 1, where R is what? Resistance of the conductor, A is what? Area of cross section, and L is the length. Now what are the SI units of this? What is the SI unit of R? Ohm, right? SI unit of area of cross section, area. We always measure in meter square. We know area, always we measure in what? Meter square. What is SI unit of length? Length is what? We always measure in meter. Now substituting all this SI unit in equation 1. So rho equals to Ohm into meter square upon meter. So meter get cancelled 1 1. So what it remains? Rho equals to Ohm into meter, right? So hence we have proved. Very easy, na? Rho equals is what is will be the SI unit of then resistivity. The unit of resistivity is Ohm meter. Hence we have proved. Now see what is the resistivity of some other materials. I have told you na, as material will vary, its resistivity will vary. Now see if the material is made up of copper, so its resistivity will be 1.7 into 10 raised to minus 8 Ohm meter. If the material of a conductor is made up of nichrome, then what is the resistivity of it? 1.1 into 10 raised to minus 6 Ohm meter. And if the conductor is made up of diamond, so what is the resistivity? 1.62 into 10 raised to 13 to 1.62 into 10 raised to 18 Ohm meter. This is just for an example to make you understand that if the material will vary, then the resistivity of the material will also vary. Okay. Now we will revise all the topic what we have learned, right? First we have gone through what is the appliances, then I have taught you upon potential difference of a cell, then electric current, then resistance and Ohm's law. Okay, then we have seen this, the working of Ohm's law, then who has invented, what is resistance of 1 ohm, then I have learn about this diagram, right, when the electrons are in random motion and how it setups when the batteries are connected, when potential difference are applied. Then we have learned about that diagram also. Then we have learned about resistivity. Then we have learned about how its unit can be calculated, Ohm meter can be calculated, and what are the materials, right, which are having some different values of resistivity. Now I'm going to give you some assignment. Take a screenshot of this assignment or write it down in your notebook and complete your assignment. Okay. So what is the first question? States the Ohm's law. Second question is, how will you find out unit of resistivity? Third is define resistance of 1 ohm. And fourth one is name the scientist who established a law of measuring the resistance. So this was our lecture about it. Everyone has taken, right? I think everyone has taken the screenshot. So I'm going to the next page.